Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Properties of Parallelograms and exactly what happens when you have a parallelogram. So let's start with what is a parallelogram. So I'm going to take this particular little thing here. It's actually just my mirror case, and I'm going to draw parallel lines. And I'm going to turn it and draw another pair of parallel lines. Okay, so I could have done that with two different shapes as well, as long as I had something, so I have parallel sides. That's a good thing. So this resulting shape in here is parallelogram. You actually work with parallelograms a lot. You might be going, you just drew a baseball diamond. I did. By the way, diamond is not this shape, okay? Most of the time if I talk about a diamond, I'm talking about a rock. So yes, I know this happens to be a square in this case, but inside a parallelogram has four sides because it has to be a quadrilateral. But the more important thing is this side here and this side here are parallel. So a parallelogram has two pairs of parallel sides. Okay? What happens because of that, it also therefore has some congruent segments and things like that in it, and that's what we're going to explore. So think about this like a box. Let's say you got an Amazon box and it's rectangular, right? And you go to fold it flat. Well, as you fold it flat, the box might shift and it's no longer rectangle looking, right? This is how you're going to see most parallelograms drawn if they're not actually a rectangle. So this side would be parallel to this side. This side would be parallel to this side. Okay. Now we know parallel lines cut by transversal creates a lot of congruent angles. So we actually have congruent angles in here as well. Okay, so we're actually going to look at that right quick. So I'm just going to number these 1, 2, 3, and 4. Okay, so angle 1 and angle 2. You'll notice they're inside the top and bottom parallel line, but they're on the same side of the transversal. That means they add to 180. Okay. Angle 1 and angle 4 are inside the vertical parallel lines, but they're on the same side of this transversal. So angle 1 and angle 4 are also 180. So 1 and 2 are supplement, 1 and 4 are supplement. Therefore, because 2 and 4 are supplement to angle 1, by that angle supplement theorem or by substitution, either one, we can now find that the measure of angle 2 is congruent to the measure of angle 4. So we have this is congruent to that. Could we go through all that same work and do the same with angle 3 and angle 1? Absolutely. Okay. Also, because of the parallel lines are always equal distant apart. So not only do you have two pairs of parallel lines, you also have two pairs of congruent segments. Okay? So two pairs of parallel lines, two pairs of parallel segments. Are the diagonals congruent though? Is this diagonal congruent to this diagonal? I'm going to really exaggerate the folding of this box. Okay, we're going to draw a really long box. And I'm going to make sure that I have the length on that to be exact. I know I'm not using the best measurement device. Okay, shift it and bring it down. Draw the same length. Okay. Connect. Connect. I now have a parallelogram because this side is parallel and congruent to this side. This side is congruent and parallel to this side. Okay, so let's look at these diagonals. I'm going to use my handy dandy measuring tool. Diagonal means opposite corner, you know, the non-touching corners. So this diagonal does not connect to this vertex. That's why we have one diagonal. So here's the length of that one. Is it the same as the other one? Whew, not even close. Okay, so the diagonals are not congruent, not at all. So we do not have congruent diagonals. However, I'm going to draw one a little different. Let's see. Get a measuring device again. Trying to make this drawing perfect here for you. Here's one of our diagonals. And here's our other diagonal. Okay, so we can definitely see in this drawing that the two diagonals are not congruent. Okay, but we're going to go with this point X, A, B, C, D. So we know BD is not congruent to AC. We know that. However, the diagonals do bisect each other. Whoops, XD. So again, we know this, just a little bit longer, is definitely not congruent, but spin my wheel in here so we can compare these segments. Anytime you're questioning this, like draw a shape. Like if you're on a test or something, go ahead, do a quick draw shape and double check with a compass. There we go. Yep, definitely. So AX and XC are the same thing. And can I keep getting down there? Now, obviously, if you're on the ACT drawing, that's not going to help you. You're just going to either know it or you're not, and those are congruent. If you're going to draw a parallelogram to help you figure it out, I would not draw a rectangle because rectangles have special properties. And yes, a rectangle has two pairs of parallel lines and two congruent pairs of segments. So a rectangle is a type of a parallelogram. And so all these properties are going to apply to a rectangle, plus more since it's a special case. So while they are not congruent, this side and this side are congruent, and this side and this side. So they are bisectors. So the diagonals bisect each other. And if you're in a geometry class that's going to expect you to know this, you might make some flashcards or something like that to help you out. That way you can really remember what's going on. But I feel like drawing special, like really not rectangular types of parallelograms really can help you see some of this stuff. So if x to d equals 4 units, and b to d is 2/3 of AC, could you find AX? Okay, well, the first thing we're going to do is we're going to come in here, and since I have traced the shape on paper, I can write on it. So use a transparency or something, trace your shape, write as you will. So x to d, that's 4. Okay, so what would b to d be? Because if I can find b to d, I can find a to c. Well, we know this is congruent to this, so that's also 4, so b to d would therefore be 8. Okay, so 8, mathematically substitution, right, is 2/3 of AC. So how do I get rid of dividing by 3? Multiply it over. So now we have 24 equals 2 AC. Notice how I didn't think of it as a fraction? Yeah. Now I can divide by 2 and find out that 12 is A to C. So A to C is 12, but I only want A to X. Well, we know these are congruent, so if the whole thing is 12, each side would have to be 6, so A to X would be 6. And that's just kind of how we're going to make sure we use those relationships. So keep in mind that you've dealt with several types of parallelograms in your mathematical career: a square, a rectangle, a parallelogram, a rhombus, when they're more specific, they have extra characteristics, but in general, parallelograms have 2 pairs of parallel sides and their diagonals bisect each other.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.